The head of NASA just said that the James Webb Space Telescope, JWST, spotted something pretty amazing way out in our galactic neighborhood. They were looking at Proxima b, the closest possibly livable planet outside our solar system. Remember how we thought we saw a city there before, but it was kind of fuzzy? Well, the latest JWST data says that the lights from that city on Proxima b are shining brighter. Plus, NASA's boss confirmed they've checked out the planet's atmosphere. The JWST used all its advanced instruments and seems to have found signs of life on Proxima b, a planet only about 4.24 light-years away. Proxima b is exciting because it might have life. It orbits Proxima Centauri, a red dwarf star that's smaller and cooler than our Sun. We discovered it back in 2016, and it lies in the star's Goldilocks zone, the region where liquid water could exist, which is vital for life as we know it. Being so close to us and in that habitable zone makes Proxima be a hot topic. But figuring out whether a planet can support life is tough. Proxima b is about the size of Earth, maybe a bit bigger, and it circles its star in only about 11 Earth days. Even if it's similar to Earth, that doesn't mean we could just move there. A planet's atmosphere is the key. It regulates temperature and makes life possible. But we don't know much about Proxima b's atmosphere yet, so it's hard to say if it's really a good place to live. Scientists are using the James Webb Space Telescope to figure out the secrets of planets like Proxima b. One of JWST's main strengths is studying planetary atmospheres for biosignatures, chemicals that could mean life. It does this by observing planetary transits. When a planet passes in front of its star, some starlight filters through the planet's atmosphere before reaching us. By analyzing that light with spectroscopy, JWST can detect molecules such as water vapor, methane, carbon dioxide, and oxygen. Biosignature gases like oxygen, ozone, methane, and ammonia are fascinating because they're linked to life on Earth. If we find them elsewhere, it could mean life exists there too. Because JWST is extremely sensitive, it can spot even small amounts of these gases. And by collecting data repeatedly, it improves accuracy. For Proxima b, JWST could reveal whether the planet's air contains water, carbon-based molecules, or oxygen. This is a huge step in figuring out whether it could support life. Since Proxima b is the closest Earth-like planet we know, it's a prime target for closer study. But life requires more than just air. Water is also essential. Even though Proxima b lies in a good spot, scientists want to know if it has liquid water, oceans, lakes, or rivers. Even ice or vapor would be important clues. Researchers are also studying Proxima b's climate, air pressure, and surface conditions. If it experiences extreme heat, cold, or violent weather, that could make it uninhabitable. Another challenge is that Proxima b is probably tidally locked, meaning one side always faces its star while the other remains in darkness. This could create drastic temperature differences and extreme winds, complicating the chances for life. Back in 2016, astronomers discovered Proxima b with a high-accuracy radial velocity planet searcher, HARPS, at La Silla Observatory in Chile. HARPS detects small wobbles in a star's light caused by the gravitational pull of an orbiting planet, a method called Doppler spectroscopy. This tool has revolutionized exoplanet hunting, and when combined with JWST, it allows scientists not only to find planets but also to study their atmospheres. Together, HARPS and JWST show how far planetary science has come. We've gone from guessing about other worlds to actually detecting, studying, and even probing the atmospheres of planets light-years away. The big question remains, does Proxima b truly have what it takes to support life? With the James Webb Space Telescope's advanced tools, astronomers are closer than ever to answering that. If we find biosignatures or liquid water there, it could change how humanity thinks about life in the universe. Even if we do discover signs of life on Proxima b, the challenge of reaching it is enormous. At about 4.24 light-years away, it's our nearest stellar neighbor. But with current rocket technology, it would take tens of thousands of years to get there. That's why scientists are also working on futuristic projects like Breakthrough Starshot. This initiative proposes using powerful lasers to push tiny spacecraft, no bigger than a microchip attached to light sails. In theory, these probes could travel at up to 20% the speed of light and reach Proxima b in just over 20 years. If that dream becomes reality, humanity could, for the first time, get a close-up view of an exoplanet. Imagine the images of its surface, its skies, or even its oceans, if they exist. A mission like that would forever change our understanding of life beyond Earth. But even before we send spacecraft, telescopes like JWST are giving us a head start. They're teaching us not only about Proxima b but also about hundreds of other exoplanets. Some of these planets are super-Earths, larger than our planet but still rocky. Others are mini-Neptunes, with thick atmospheres and possibly hidden oceans beneath. Each discovery adds to the puzzle of how common habitable worlds might be in the galaxy. What makes Proxima b special is its closeness. It's like the cosmic backyard experiment. If life can exist around a small red dwarf star so near to us, then it could also exist in countless other star systems scattered across the Milky Way. Since red dwarfs are the most common type of star, this increases the odds that the galaxy is full of potentially habitable planets. Still, many questions remain. How stable is Proxima Centauri as a star? Red dwarfs are known for violent flares that could strip away a planet's atmosphere. If Proxima b has no magnetic field to protect it, life there could be constantly under attack from radiation. On the other hand, if it does have a strong atmosphere or magnetic shield, life might thrive despite the challenges. That's why every observation from JWST matters. Each spectrum, each measurement of gases, and each glimpse of starlight filtered through Proxima b's air adds a piece to the puzzle. With time, we may finally know if our nearest neighbor is a barren rock or the first alien world with life we've ever discovered. If we do confirm that Proxima b has life, even in the simplest microbial form, it would be the most groundbreaking discovery in human history. For centuries, people have asked, are we alone in the universe? A positive detection would finally give us the answer. It would prove that life is not unique to Earth, but a natural outcome when the right conditions come together. Even a planet with only microbial life would revolutionize biology. Scientists could compare DNA, or its alien equivalent, with life on Earth. If the biochemistry is similar, built on carbon, water, and amino acids, it might suggest life everywhere in the universe follows the same rules. But if Proxima b's life is completely different, based on an exotic chemistry, it would show that nature can invent multiple ways to spark biology.